Hello, and thank you for attending this webinar. My name is Samir, and I'll moderate today's event. My colleague Daniel will present some of the many compelling features in Maple 2016 for educators and researchers. Before we get started, a few points of order. If you have any questions for Daniel, please type them into your chat box on the bottom right-hand corner of your screen. Daniel will answer several questions at the end of the webinar. Any questions that we don't get to, we'll answer via email over the course of the next few days. If you have any technical issues, please refer to the event registration email for support information. And now, without further ado, I'll hand over to Daniel.
Thank you, Samir. So this is our talk for what's new in Maple 2016 for educators. And there's a lot of features I'd love to spend time talking about today. But we want to just kind of make sure we spend some time with a few features that hopefully have the most impact for you to add value to your classroom, to enrich your students' experiences, as well as to kind of bolster any researcher's toolkit. So I think what we'll spend a majority of our time talking about today is going to be features like the new workbook project file format. As well, we'll discuss some examples from the Thermophysical Data package. I want to show some examples from the new rich data frame container. And I also want to show you a couple of applications. We're going to show some math apps, some examples, some applications from those subject areas, as well as other areas like number theory, other topics taken from advanced math. But I think at this point, I'm going to start off by talking about the workbook. And I think what I'd like to do this year is a little bit different. Usually what I'd do is I continue on using Maple's slideshow mode and walking through the rest of this slideshow with you. But instead, I'm going to open up a new workbook and use the Workbook Explorer itself to basically give us a way to navigate through this presentation. So to set up this example, I've actually opened up a new workbook. And what a workbook is, it's a container file format. It stores together all your Maple content in one file. So here you can see my example for workbook. It contains my first worksheet here. It's called Workbook. Then I've got some images, so the image you see right here. As well, I've got some attached code scripts. And then I've got another example that shares content with this original worksheet. And this is all stored within this one new file. So it basically collects everything together for you in one place. This means it's a little bit easier for you to take that file and to share it with students or peers. Now, working within the workbook, we have a Workbook Explorer. You can see over here within our Palette tab, there's a new Workbook tab. You can do things like we can quickly add in a new document. So here we can make our new document. And this is a new worksheet that we can work away with. You can use it as a scratch pad. But you'll also notice that it can use any of the attachments that are shared common throughout this workbook. So down here, I see in my variables palette, I can see that there's a shared variable called P1. If I type in P1 here, this is actually loaded within this worksheet. So you can see that this is common now through this worksheet as well as through other documents. So another aspect of the workbook that I find particularly useful is the notion that I can share data files or photos or images through the Workbook Explorer. So here, for example, we've added in a CSV file. If I double click on this opens up in Excel. I can modify the values if I'd like. But what's important here is that I can use this file. I can use it within my workbook presentation if I scroll down here. So I could read in this attachment. This is actually coming here from this. You can actually right-click here and grab the path if you want to copy this straight path out of the workbook. So you can use it within this document. I can use it within, say if I open up this attached worksheet here for the earthquake data analysis, I can again use the same CSV file. So I have one CSV file that's shared between multiple Maple worksheets. So this gives you a more efficient structure that lets you collect together all of your Maple content in one place. So this is kind of one example of a workbook we've generated. But if I go back into my presentation for Maple 2016, you can see here's another example where I've put together my first initial slide for Maple 2016, as well as my additional examples I'll be showing you today. It's all shown within this navigation hierarchy. So to me, this is really, really invaluable. It's really changed the way that I've worked within Maple. And it's made it much easier for me to work with data files, as well as any other attached files that I want to work with. So you'll see me, I'll be using the Workbook Explorer. We're using the workbook more for today's presentation. But at this point, I'm going to move on. I'm going to talk about our second big feature. And this is the new rich data frame container. So to kind of quickly mention what a data frame is to begin with, a data frame can be really just looked at as this. It's kind of a rich matrix. This looks a lot like a matrix in Maple, but the key difference here is that we add in things like meta information. So here I've got column labels. So there's column labels here corresponding to these variables. And there are row labels, and we kind of consider these to be observations. So I've got observations here for 4 observations. As well, an important part of data frames is how it hooks into Maple's offerings. So here we can see is a unique visualization that comes out of using the data frame container. But again, examples really bring this stuff to life. So let me show you an example. I'm going to pull this out of our workbook tree here. So show you our first data frame example. And this is an example I've put together. You'll find this within the Maple Help system as well. It clicks together some properties of 4 berries. So we've got our 4 observations here for raspberries, grapes, strawberries, and blackberries. And we're looking at 5 variables. So there's the genus, energy, carbohydrates, total tons, and top producer. Now, a unique part of the Maple data frame, and this is how it really differentiates versus a matrix, is that it stores heterogeneous data. So here we see the genus. This is a collection of strings. The energy is a collection of integers. Carbohydrates is floats. Top producer is names. So this is an important facility that we can actually take different types of data and put them into one container. Another important aspect of the data frame, I'm going to open up a couple new prompts here. Previously in Maple, if you had something like a matrix called berry data, which stored your data, you would need to index into it using this square bracket notation. So we do, say, berry data square bracket 3 in order to pull out the carbohydrates column. Now you can still do that, of course, but what the data frame adds is the ability to also index into a data frame using a name. So here instead we can use you can use the data frame berry data, and we can index that by carbohydrates in order to pull out the carbohydrates data series. And this is the first time I mentioned data series. So data series are kind of a one-dimensional version of a data frame. We're just looking at each one of these columns individually. That can be considered a data series versus the data frame, which is the 2-dimensional container. Now what you can do with a data series is you can actually index it. You can index it, you can query it for different attributes. So if we looked at, say, the energy data series, so we can look at the berry data energy, and we can query which values are greater than a certain given value. So here I'm going to say which values in the energy data series are greater than 200. And what this returns to us is a true-false data series. So we can see now that raspberry meets this criteria, grape meets this criteria, but the other ones do not. And if you take a true-false data series and index that into your data frame, what this will actually do is it'll apply filtering. So now when I use this query to index my berry data, it actually returns the rows that meet that criteria. So this is actually a way of subsetting your data. You're actually able to more easily work with your data constructions inside of Maple. Now an important facility, or an important part of what we were going for when we started talking about working with data frames in Maple was we wanted to make sure data frames were a little bit Maple-ish. And we kind of wanted to add in lots of top-level support for data frames. So one of the commands you can apply to a data frame is the with command. And I'm sure a lot of people have used with before. You've used it for loading a package, we'll say. If you do with of a student package, you'll load that specific package's commands into Maple's top level. Now if we do with of a data frame, that actually loads a data frame's columns or a data frame's variables into the top level as new variables. So once we load the berry data frame, we can then just run carbohydrates, and this returns a data series for us. So this makes it a little bit easier because we're always just kind of working with a variable name instead of working with an indexed notion of a matrix. So that allows us to kind of cut down on our queries. We can do now something like berry data, where we're looking at values of energy greater than 200 and carbohydrates less than 15. And you notice this now pulls out that one row. So this obviously is only raspberries that meet this certain criteria. All right, so let me move on. I want to show you another example for data frames very quickly. And for this example, I wanted to talk a little bit more about the other areas that the data frame's hooked up. So the data frame, we made sure to try to integrate it into our statistics offering as much as possible. In addition to that, we've also made sure that it's hooked up through things like our import command. So import, if you haven't used it before, it's just a kind of a generic import mechanism for CSV files, Excel files, whatever you've got. But if import sees a file with some header information, some column headers, it'll actually import this as a new data frame rather than being imported as a matrix. And when it does so, you actually get the added benefit of having these column headers loaded automatically for us. As we saw before, the data frame can contain different types of data. So here we've got 4 variables for this data set, which are floats, and then we've got 1 which contains strings. So now, before we move on, just a bit more about this specific data set. So this collects together 150 observations on irises. And they're actually in 3 separate subspecies of iris. So with that knowledge, we can also maybe say, OK, we want to know a little bit more about the numeric side of this data set. We want to perform some summary statistics on this data set. Now, we can do so using commands pulled out of our statistics package. Something like data summary on this would do that. But this is also all available through the right-click context menu. So if I choose to go down to the bottom of our right-click context menu, we'll see data summary here at the bottom. And we can now use the column selector in order to pull out the 4 numeric columns, because these are the ones we want to get actual summary statistics on. It doesn't give us a lot of information if we run summary statistics on a column of strings. And we can display this with an embedded table with this option here. I'll press OK. Now this returns some summary statistics on this data frame. So this is one way we can now quickly look through. We can see for each one of the numeric columns, we can get a 7-number breakdown for each one of these. But then there's also other commands that we can start to work with and use for data frames that are unique for the data frame. One of those commands I'd like to show you is the aggregate command. So we know from before that the species column contains 3 distinct species. So if we choose to aggregate by column and choose the species column to be the aggregate column, we can then perform a statistic based on given our list here. And then we can show a tally as well. And what this gives us is a breakdown for each one of these individual levels contained within the species. So you can see that, in fact, the overall mean, which was 5.84, is different than the 3 subspecies means. So the aggregate command gives us a different picture into our information. So staying within the realm of statistics for a moment, we've added some more commands that work with data frames as well as matrices in Maple. And one of the newer facilities we've added is a command for principal component analysis. And what principal component analysis seeks to do is to take some larger dimensional data set and reduce this down to a couple of principal components, we'll call it. So a couple of dimensions where we look to have the maximum variability for those dimensions. So if we apply this to our data set, this iris data set, the results from this is we return a record. We can query this for values, for the principal components, for the rotation matrix, and so on. But perhaps the easiest way to visualize the results of a PCA is through something called a biplot. And a biplot gives us our 2-dimensional subspace for the principal components. So here's our first dimension, which accounts for 92% of our variance. Dimension 2, which accounts for 5%. We also see our points, which have been projected into that subspace, as well as each one of our variables. So here we have petal length and petal width. We can see that these kind of overlie one another, so there's probably a little bit of correlation we can see between those two. In addition, sepal length is all moving in that same x direction as these two, so we could also probably think that there's probably a great deal of correlation between these ones as well. But then sepal width moves off in a slightly different direction. It moves kind of further down towards the y. So these may not be as correlated as the other ones. So this is just kind of one of the first steps of the types of tools that you might use to start to analyze your data frame data. But let's move on. Let's discuss next the Thermophysical Data package. So this is an interesting new package for us with Maple, specifically because we've, around it, added a lot of new applications. And that's really the story of thermophysical data, is what you can do with it. On your screen now, you'll notice that there's a number of different applications. These are all available inside of Maple. So the types of things you can do with thermophysical data, it varies, but For the first and foremost, what you can find is you can compute thermophysical properties of pure fluids, of fluid mixtures, as well as humid air. And with this, you can do things like you can model heat flows across thermodynamic cycles. You can calculate the efficiency of solar heating systems. You can simulate models of heat exchangers with lumped parameters. You can optimize the performance of turbines, and a lot more. So again, I mean, this is kind of giving you some general ideas what we can do, but let's actually have a look and see what this looks like inside of Maple. And I'm going to run this example, so the psychrometric chart example, with a couple of extra examples added. So the first thing I do is I load the Thermophysical Data package. So these are the commands that are available within that package. One that you'll often use is the property command. And the property command we can use to do things like return the density of a 3070 molar mixture of helium and nitrogen at a given temperature and pressure. So here we can do property, density, we can set our temperature, and you'll notice when we're setting our temperature, we can actually modify units here. So here we've got it set to Kelvin, but if you want to change that to degrees Celsius or Fahrenheit, you can do so there. As well, pressure, we can change this from one atmosphere to other different unit systems and so on. So the key here is that the Thermophysical Data package is units aware. You can see that in the result as well. So here's our result from the property command. And we get back a result with an associated unit. Now if we'd like to, we can obviously apply units formatting. So I'll change this from metric to imperial. And we have that result. Now if we go back here, we can change the temperature, and we can get an updated result as well. One other thing I'd like to show you within Thermophysical Data is the psychrometric chart for humid air. And this is actually also using some new functionality with our embedded components. We have a new hover event on plot components that as you move your mouse across a plot component, you can see it returning results. So in this case, for the psychrometric chart, what we're doing is we're calculating thermophysical data for the current dry bulb temperature and humidity ratio, which you're seeing this up here in this top left corner. We're overlaying this information on our chart. So it kind of gives you an all-in-one environment for seeing and working with this information. So staying within the notion of Maple's application offering, Maple has a lot of math apps. I think last told, I think we're way over 400 at this point, but we have a lot of different content, and a lot of this content is aimed at the classroom. So the thermophysical example I just showed a second ago was that's a little bit more of the engineering side of Maple. It certainly can be used for any course that you're working with thermophysical data, but a lot of these other examples, they're kind of more to the core of mathematics courses, statistics courses, things like this. And if you haven't seen math apps before in Maple, let me show you an example. We'll pull up this sieve of Eratosthenes example. And a math app is a pretty simple concept inside of Maple. We start off by outlining the subject matter. We kind of give a breakdown where we discuss it. And then we have an interactive interface. So I'm going to start this while I'm continuing to talk about it. You can see here with our interactive interface, this actually generates an animation. And here you can see we have our legend, but we also have control over the number of rows, the number of columns, and the speed. So this is just a way for us in this example to show primes as well as their multiples. But really what we have here is a fully interactive interface that you can just have a student open up. They can read more about the information about the concept behind this, and they can just play with the math. They can play with just buttons and dials and gauges in Maple. So that's one example shown in Maple, but an important part of our offering with math apps is the fact that these math apps can all be shared online as well. And if you go to our website, which is maplecloud.maplesoft.com for math apps, you can interact with the content we have available for you. So here's a new math app for tessellations. So I can just interact in the same way that I'm interacting with a Maple math app inside of Maple. I can interact with this in the Maple Cloud as well. So this is really important because what this means is that if a student who doesn't have a copy of Maple, or a student who has a tablet device or a mobile phone, can just go to this website in order to work with content that you've created inside of Maple. So not only do we have the cloud, we also have a free Maple player, but that usually requires a PC. It's an installable program, but it's another way for you to deploy your content. But the cloud, I think, it's really, really vital, and it's really important moving forward that your content is as accessible to as many students as possible through as many mediums as possible. So now if we discuss the notion of actually authoring applications, so those math apps I just showed you, those were all authored using Maple and the Maple programming language, as well as mixing in some of our embedded component technology. The explore command, for those of you who haven't heard of it, is a way to very easily create interactive applications. What it does is it creates a central display component, as well as some controllers, such as sliders, dials, drop-down boxes. So in the last example you saw, we had a central display. That was our plot that was running through. And then we had some sliders, we had some buttons that we could then customize the interface or get some different information out of it. And what this does is it gives you an interface to explore mathematical expressions or plots or images. And usually for Explore, we're making sure that we're doing this for a given parameter set. So I'll show you an example in a second, but there's a number of updates which have gone into the Explore command for Maple 2016. And I won't read this whole list, but certainly my favorites have to be things like the simplified calling sequence. It's easier to use because we have to type less. The option to record plots, and then also color customization. This is a really neat one because we can actually totally change the layout as well as the color schemes used for your explorations. So again, let me show you some examples. So I've got two examples. So the first one here is explore of a plot. And here, this one is showing off the new simplified calling sequence. So previously in Maple, I would have had to type parameters equals and then square bracket a equals 1 to 5. But now it's just to enter in a equals 1 to 5, and Explore just uses that as its parameter. Now, just to recoup what I said before, what Explore does is it generates a plot as well as an interactive device. So you've essentially got output and input. We can use a slider to change our parameter values. You can see the parameter a changing here from 1 to 5. And you get the output on the plot above. As I mentioned before, one of my other new favorite features of Explore is that we can modify the component background color. So in this case, we can set the color to be black. The fill color of the entire inserted component region, which can be light blue, and the font color. So this is the font color you see here and here. So again, we've used this just to insert a simple 3D plot, but it can insert this type of interface. And once you've got this interface, you can then take this interface, save this independently, put this on the cloud, put this or just save it in a Maple worksheet file, and you've got content that you can share with your students. So I'd next like to move into kind of the area of advanced math. And I won't cover all the features that we've added for Maple 2016 in depth today. There's a lot of new features for Maple 2016 that for various things like graph theory, group theory, for logic. There's so much you can talk about. And I would certainly encourage anyone who's interested to go into our What's New pages and have a look at this stuff. But I wanted to spend some time first talking about our function advisor. And the reason I want to do so was it's very similar to what we saw with Explore in that it can create this type of interactive interface for exploring and generating general information on mathematical functions. So let's open up an example for the mathematical function advisor. And you can access this just using the command function advisor, whose first argument is a function you want to explore. So in this case, let's explore the function EI. And I'm going to go up here, edit, view, sections, expand all sections, just to give you an idea of what's returned here. So what we return when we run the function advisor is a collection of information about this function. So we see here, EI is the exponential integral. We can see its definition, analytics extension, periodicity, as well as plots. We can visualize this. You can scroll down, you can look at the branch cuts, special values. You can get a whole bunch of information about this function. Now, if you're interested in just returning the plots, you can supply an argument to the function advisor, plot. So here we can do Jacobi SN. We can return an array of plots here in 2 and 3 dimensions. And we'll do another example just for fun, too, of another function we can run with the function advisor. So this is a great way to return an interactive interface, to return kind of a general breakdown of these functions in a nice worksheet viewable way. So as I mentioned, I won't go into depth about a lot of the other advanced math topics, but I did quickly want to mention the number theory package. So previously in Maple, we had a num theory package, and we've gone through for Maple 2016 and updated it to become the new number theory package. And it basically updates a lot of the functionality, makes the commands a lot more efficient, What we've also done at the same time is we've added a lot of new content. So there's new math apps. But then there's also a lot of additions that have gone into the context menu. So for things like, hey, say if we have a fraction here, 3/7, we can right-click on this and now show this as a repeated decimal. Same thing with 3/7, we can right-click on this and show it as a continued fraction expansion. So there's kind of this notion that for number theory, we've hooked up a lot of the functionality directly into a context menu. So this is just the number theory more page that I've opened up for you here. But you can see here there's lots of new examples as well. I mentioned before there was lots of examples for Maple. So there's lots of new examples that have gone into number theory as well as math apps. So there's a lot of new content that's available there for the number theory package. So another area I wanted to quickly cover, and I covered this when I was talking about the data frame, is our statistics functionality. For statistics this year, what we've added is a lot of kind of facilities for doing this similar to what we saw with the function advisor, kind of ways to generate some embedded content that helps you to summarize systems. So if I go back here, there's a fit command in Maple. If you've given it, say, a couple of vectors of information, you can fit a command, an expression, to that information to see what that equation of best fit is. So what's new in Maple 2016 is that you can also return an embedded summary. So here we get an embedded summary of our regression model. So here we see is the model. We can get the breakdown of the coefficients. So here we see the coefficients A, B, and C from our model, as well as their estimates, the standard error, and associated t-values and their probabilities. Now, if any of these was significant, these would be actually in bold. In this case, none of these are, so we're not actually showing them in bold. But another important facility here, too, is that we've added r squared and adjusted r squared to this summary. So there's a great breakdown. You can also get more information about residuals here. And the nice part about this is, similar to the other stuff, you can just copy this out, you can put this in a report, and you've got an embedded table that collects together all the information about your model. So this is just kind of another way of generating nice-looking content that can be used in reports. And speaking of nice-looking content, I'm kind of rounding out my slide deck now, but these last few slides are kind of some of the slides that I would consider to be among the most useful and pertinent to most Maple users. So I think at this point, most people are aware that plotting is really one of the most important facilities within Maple. This is really what touches on almost every single Maple user. Everybody likes to plot charts, they like to plot graphs, they like to explore mathematical expressions. This is just something that's common throughout. So what's important for plotting is that we not only add new visualizations, but we also work away at existing plot commands to make them more efficient, as well as to add in new options that make them just that much more useful. So I mentioned before biplot. You saw that in the section for the data frame. The heat map is another new visualization that comes out of statistics. We saw there's some new visualizations coming out of Thermophysical Data. But again, I want to stress that things like new color schemes, this is a new option that we introduced with Maple 2015, but we've added new facilities to it from Maple 2016 to add in Y gradients and Z gradients, but also be able to color by points. So there's a point plot that we had a little while ago where we could actually we could actually use different colors for clusters of points. And this really expands the types of graphics you can generate using Maple. And it really makes those existing commands and what you have already been doing in using Maple that much more effective. Now, talking about clickable tools, and I think this is an important point because when I speak to educators, one of the things we often talk about is the workflow for their students, when the students are learning to use Maple for the first time. And with Maple, we talk a lot about this natural math and language and how you can enter in an integral and it looks like an integral. But we also have this notion of having lots of tools that are clickable in nature, that you can just click an expression and it just pops into your Maple worksheet. It looks like the way you would expect it to look. So to that end, we have a number of palettes. We have palettes for entering expressions, for calculus, and a lot more. But for Maple 2016, we've added a new palette for group constructors. So this comes from our group theory package, and you can quickly use the group theory constructors palette to generate a number of known groups. In addition, talking about the clickable tools, we've got additions for number theories you saw before, but then also we made sure that the data frame has a completely customized context menu. So you can right-click on a data frame or a data series and apply a number of commands directly to that data frame using the right-click context menu. In a lot of cases, it actually makes it easier for you. I showed before an example from data frames where we visualized a data frame. And actually, it was a data summary for data frames. And rather than having to type out the command and fill in all the column names, I was able to just select from a drop-down list the columns of numeric information that I wanted to use. So this actually saved me time. I was just able to right-click, select numeric columns, return a data summary. So in this case, it actually gives you a workflow that saves you time and makes you get to this result that much faster. Now before we end, I wanted to show a couple more interface options that have been added. And these are often, of course, of most use to everybody. And these things often come from direct user response and user requests. So the first one I want to show you is the ability to toggle between executable and non-executable math. So let me open up a new worksheet here just to give you a better idea what this looks like. I'll scroll in a little bit here. If I open up a new Maple worksheet, by default, the document block here that we see, this is a math entry prompt. It's in this kind of a light blue color. And when we have this light blue, that means it's an executable section. If I type in something like 1 plus 1, this executes when I hit enter. If I go back here, though, if I enter in something else, something like this polynomial here, we can change this from being executable to non-executable by using Shift F5. And what that means is if I hit enter on this, it won't execute. So before in Maple, you might have to right-click, you might have to change it to NERT or something like this, but we wanted to make sure there was an easy way for you to take your math, which was executable, and make it into non-executable math and have it really marked as such. So you see the background here is changed to a gray. So there's some type of notification that you are in a non-executable area. You can also change that using this little pop-up that appears in the top right corner of your expression. If you click on that, that'll also change it back and forth from being executable to non-executable. But again, this was one of the most common requests we had, because what we saw was when educators were using Maple, they were doing something like, they were mixing in text and math, right? We were typing out some text, then we had some math. But maybe the math it was just purely there for a typesetting. So instead, we're using this now as a non-executable region, so we can mix in text and non-executable math to give the look and feel that we would want to have. So another one that I want to mention very quickly is the ability to move a preceding term to a denominator in a rational expression. Again, I'll move to a new worksheet here just to make this really clear for everyone. So say we had entered in something like x plus 1, and we realized after the fact we actually want to make this into a denominator. Now, it's easy enough to do if you've typed in 1 and you start working away in the denominator, but what's actually nice and handy now is that we have the ability to just do / and move that denominator around. So the first one moved it to the forward. We would actually be able to put a denominator below it, but a second hit would actually make it such that we can use that whole term in the denominator position. So again, that's just a //. Now something you've seen me using over and over again throughout this presentation today has been slideshow mode. And previously in Windows and Linux, you could use F11 to move into a slideshow mode. But for Mac, this wasn't possible. So we've actually added a command key, so Control-Command-F, to move into a slideshow mode for Mac. Now, two more options I want to quickly mention are the zoom level. So for zoom level, it's now a global setting for all of your Maple documents. You can actually view it down here in your bottom corner. You can see that my zoom level here is set to 150%. But if I go into my Tools Options menu, go to Interface, I can change my default zoom to say be 200, apply this globally, and then have that applied to my Maple worksheet. So this is a change from before. So before, you would have to manually change the interface for the zoom level for each individual worksheet because it was stored with a worksheet. But now it's kind of more like a web browser. If you have your zoom level set to 200, then whatever document you open up is set to 200. So there's no more kind of going through and modifying the zoom level manually. And another point I wanted to leave you with was that we've added a control of the display of section arrows. So, and this came, of course, from educators. They were using Maple to typeset some report, some document, but some people may or may not like this section arrow here. So if you right-click on a section, what you can do now is right-click, Section, Hide Arrow, and Stay Expanded. And this hides that arrow, but it keeps the section expanded. And I'll go into our help system for a second here. Let me open up our plot help page. Nowhere is this more apparent than in our help system. So you can now see that our help system pages have been updated. We've removed the arrow. Instead, we've flattened out the pages. with the flattened pages, we've had to do things like add a table of contents, so you can quickly move down to the examples if you want to see just the examples. This kind of gives it a nicer appearance. So that way, if you wanted to, say, take this and to export this to a PDF, you have a much nicer, much more slick looking presentation. So this leads us to where we basically started off. This is our kind of high-level picture of what's new in Maple 2016. I haven't had enough time to speak to all these features today. I think we could probably spend hours going through each one of these in depth, and we very well may do so for a number of upcoming webinars that we have scheduled for this coming year. But there's so many new features in Maple 2016 that I would certainly encourage you to give it a try. If you're inside of Maple 2016, this same slide deck here, you can view a lot of these content through the What's New in Maple 2016. So you go Help, What's New, and this will give you that same breakdown. And if you wanted to get more information about, say, what's changed in graph theory, or what is the new iterator package, you can just click on one of these. It'll bring you to a What's New page, which gives you examples, it gives you content that you can work with. All right, so I think at this point, it's probably a good time to move on. Well, I think we have some time now for some questions.
Well, thank you, Daniel, for that very compelling demonstration of Maple 2016. We've had a number of very good questions come in today. I think we probably have time for 3 or 4 questions. The first question actually touches upon my favourite feature in Maple 2016, the Maple Workbook. It really has changed the way I manage my Maple-based projects. One of our delegates wanted to clarify if the workbook was a single file on your computer.
Yes, yeah, it absolutely is. So, and that's the unique offering that the workbook has. Is you can see here, this is my Maple 2016.maple format. So this is actually a new file format for Maple. We actually called it a .maple file, but it's stored on disk. Here's my content for today's webinar. You can see here, Maple 2016.maple, and this stores together all this content here. If I look at the workbook example, open this up in Maple. So this is the example I showed just near the start. This is the same. We've got the same workbook. It's CSV files, all its content. It's all stored within one file. So again, this really makes it much easier to work with. It makes it easier to send to your peers. It just makes it easier in general for the deployment of Maple applications.
Thank you. So we've had a number of questions come in about the Maple Cloud. I think you touched upon it briefly in your presentation. The first question asks, is any special licensing required for the Maple Cloud?
That's a good question. I think potentially the question there is really, is the cloud free, which it absolutely is. There's no license involved. You don't have to buy anything when you're using the cloud. All you really need is a web browser. You need a tablet device, you need a phone, you need a computer. You need something that can just go to this website, maplecloud.maplesoft.com. Once you're there, you can browse through our math apps. You can browse through the public Maple Cloud, as well as if you have a MapleSoft account, you can browse through any files that you've uploaded to your own private cloud. So you can actually use this as a way to store your own Maple applications and see them online. So it's all online, it's all free. You don't have to have a copy of Maple. It helps if you do to be able to author the content, but for the students who may not have a copy of Maple, they can just use the cloud online.
Thank you. That was a great answer. I think we have a number of students who've attended this webinar today, and we've had a number of questions about the various student packages in Maple 2016. Let me just summarize those questions. Were there any updates to the student packages in 2016?
So there were a few. I think if I go back here to the What's New Maple 2016 page, you'll see that primarily it's focused under this student multivariate calculus page. So if I go into this What's New page, you'll see here that there's 6 new commands that have been updated for the multivariate calculus page. But I think what's even more important to the student multivariate calculus package is that a lot of it has been now hooked up through the context menu. So we try to strive with each one of our student packages, and if you're not familiar with the student packages, each one of these packages is kind of aimed at a first-year course or a specific course. We have Student Calculus 1, we have Student Multivariate Calculus, or Student Vector Calculus. There's something there for numerical analysis or linear algebra. So each one of these is aimed at a course. We want to make sure that those courses are as interactive, as clickable as possible. So a key addition for Student Multivariate Calculus is being able to take an expression that you have, right-click on it, and apply things are commands from the multivariate calculus package. So use the tutors. You can all find that through the right-click context menu. So those are certainly invaluable additions which have gone into the student packages.
Thank you. I think we have time for one more question today, and I think this is probably my favourite question. You've shown us the big stuff today, Daniel, but there's always more. Our delegate asks what your personal favourite small improvement in Maple 2016 is.
Well, there are many. I think, as we saw in today's presentation, there's a lot of content in Maple 2016. There's a lot of the big features. I've talked about workbook and data frames. Those are two of my personal favorites, but I think some of the features that I've had the most use of so far is probably down here in this interface section. Being able to toggle between executable and non-executable math, that's helped me a lot when I'm executing using the triple exclamation point through my Maple worksheet. So it's helped me to make sure I don't have some math that is not executable, which actually does accidentally execute. Then I think the zoom level has helped probably the most. So I think having a global zoom level, having it shown in your Maple interface, having Maple use that all the time, it's really helped a lot, because what we had before was Maple worksheets with different zoom levels. And if you were to open it up and you had, say, a zoom of 100, but you preferred to have zoom of 200, it was always hard to read, or you'd have to go in, you have to just change the zoom, and you have to resave, and it was a pain. So I think having a default zoom just makes it that much easier to work with a Maple interface.
Thank you, Daniel. So I think we've had a number of very good questions come in today. We've answered all of the questions that we have time for today. As I said at the beginning of this webinar, any questions that we haven't answered, we'll answer via email over the course of the next few days. And of course, if anything does come up over the next week or so, if you have any other questions, then please do let us know. And with that, what I'd like to do is end by thanking everyone for attending this webinar. This webinar will be available on our YouTube channel. Thank you for attending today.